Morning, Lungi.
Morning, Janice. How are you?
Good, and you?
Good, thanks. Can I just try to share my one slide and see?
Yeah, that's sure. Tell me, can you see the people waiting in the lobby?
Let me see.
From your side?
Yeah, I can view. Sfiso's there. Prishni is also in the lobby. Oh, she's joined. And then you can allow Sfiso in.
Okay.
I'm not sure about Nolwazi.
Yeah, no, I think she's just one of the attendees. I think at the moment we'll just allow for presenters.
Okay, great. Okay, let me. Morning, Sfiso. Morning, Prishni.
Good morning, everybody.
Morning. Morning.
I'm just sharing my one slide.
Oh, I think I should stop sharing. Let me stop sharing. Okay.
Okay. You can see it well on that side?
Yeah, we can see it. It's perfect.
Okay, perfect. Akash is also in the, thank you, in the lobby. You can lead him in.
Yeah.
Morning, Akash.
Hi, morning, Lugi. Morning, everybody.
Good morning.
Can you please share your slides just to check?
Sorry, say again, Lugi. Share slides.
Yes, just to see if everything's working well.
Sure, no problem. You guys can see that?
Yes, we can. Thank you.
All right.
Morning, Priyan.
Morning, everyone.
Morning.
Morning.
Please, can you also do the same?
Okay. Give me a sec. Okay. Oops. Which one are you seeing? Oh, no. You're seeing my main screen, right?
Yeah.
Okay, perfect.
Just to check, Janice, will you do the welcome and then hand over to Sifiso?
Sifiso can start, Lungi. It's fine because I'm doing the closing. I don't wanna.
Okay.
Yeah.
All right. No.
Okay.
Fine. Great. So Sifiso, you'll take over from 10 o'clock and then.
Who's first?
Thanks.
Sorry, Lingy, did I not get the agenda? Who's doing the first presentation?
I think it's Akash.
Okay, perfect. Okay.
No, I'm going. I'll do just one slide overview of the partnership, and then we'll go into the actual presentations.
Okay.
Okay, so you want me to go first then, okay?
Yes, please, Akash.
All right, no problem.
Lungi, the third speaker has not joined us as yet.
Yeah.
Santi.
Let me just contact him. He's back home,
Thank
so should be here. Okay. I can't get hold of him. Very strange, but
I think then maybe we can have him go
last.
last.
Mm. Speak of the devil. He's on.
Hello.
Good morning.
Morning.
Good morning.
We're just doing a pre-check. If you can put up your slides just so we see that everything's working well before we start.
Sure. Wait a second, I'm just opening. I can start if you want. Hello?
Hi, Santiago. I'm not seeing any visuals. I'm unable to see a presentation.
Let me see. Can you see it?
No, still. Lungi, are you seeing anything? On my side, I'm not seeing anything.
I'm also not seeing anything.
Okay. Because apparently I am sharing.
Okay, maybe to stop sharing and try again.
Can you see me? Can you see
Okay,
it?
yeah, now we can see it.
Yes, you can see it.
Yeah. Cool.
Maybe
Because-
you can change your display settings, Santi, because we see the next slide as well.
Sorry, the problem is when I share, I have a big problem with my Teams. Each time I try to share it, it shut down the program. So that's a problem.
Maybe you can email your slides and then we'll share on your behalf.
Let me check. Let me check. I'm now. I'm testing the browser, not the app. So let me
Okay.
check.
Okay, we have 2 minutes before we start.
Can you see it?
Now we're seeing your screen.
You see it?
Yeah, now we see it. Just go to presentation mode.
You see the big one or the small one?
We can see it, but it's not yet on presentation mode. So you just need to put it on that mode. And now you're back to your screen. You had it there.
Okay, let me check. What we can do is one more time. Okay. Can you see it
Okay, now we can see it. Yeah.
in presentation mode?
Yes, it's in presentation mode. It's
Okay.
perfect. Yeah.
Perfect. Thank you.
Okay.
Perfect. Thank you.
Good morning, colleagues. I'm sorry to join late. I've been expecting to join, but yeah, Jenny's assisted on that regard.
Morning, Smiso.
Morning.
Morning.
All right, colleagues. I think the invite said we are starting at 10, but due to people still joining in, maybe can we allow them maybe 5 minutes to join? Then we start exactly 10:05. So we give them 5 minutes to join. You know, if you have more are coming, then we keep on accepting. So the official start of the webinar would be 10:05, just to allow people to join in, so then they cannot disturb the presenters. I think that is fair enough. In 5 minutes, it's more than enough. Thank you.
Yeah, that's fine, Smiso.
All right, no thanks. So let's allow, yeah, just give them 5 minutes. Then 10:05 will officially start the webinar. Thanks. So to those who've just joined, we've allowed people 5 more minutes to join. So you're on the right platform. So don't be surprised if everything is mute. You know, we'll officially start the webinar at 10:05. So we're allowing for people to join. So we're just giving them 5 more minutes to join. We only start at 10:05. We are sorry about the delay, but we felt that it's, you know, it's fair, you know, just to give more people an opportunity to join us, so then they not miss the presentation, because today's program, it's packed with nice presentations. So we just we want to make sure that everyone doesn't miss anything. So we'll officially start at 10:05. So just in case you're wondering why there's a silence or why everything is on mute, thanks. Okay, colleagues, let's officially start this webinar now at 10:05, just in the interest of time, and then also to be fair to people who've been here at 10. So I think we've given people enough time to join. So welcome you to today's webinar. The webinar, it's between our can
Any crusher, yeah.
so can people mute who? Yeah, miss. Thank you so much. So today's session will be driven by Sifiso Simpiwe Dlamini, if I'm not mistaken. She'll be sharing this session. So I'm just giving you the logistics, then I'll give her the platform. So people, for those who've got an option to mute, can they also unmute themselves and then also try to minimize the use of video, for the sake of bandwidth. Some people might be struggling with the with the connection, so just to make it easy for them, if there's no need for you to use video, please mute the video. Let's just keep on the voice session. And then also, yeah, yes, I think that's the most important thing. And then maybe I'll get an opportunity right at the end. On this case, on this time now, I'm giving to Usimpiwe Dlamini. I think she's from our EWS. Do people still collect such data? Can people please be on mute? Simpiwe, can you please share the session? I think you were, yeah, I think that's what Lungi said, that you'd be sharing the session. Thank you. Over to you.
Yeah, welcome colleagues. Thank you so much, Smiso, for just going through the housekeeping rules for this webinar. Thank you so much for all of you to really take your time to join us for this EWS and UKZN webinar. I am Sifiso Dlamini from the WASH R&D Center, and I will be chairing this webinar on behalf of Mile and eThekwini and UKZN. I believe that this year is a very, very special year for our industry because there are a lot of events that are really happening, and there's a lot of work that has been happening on the ground that is really coming to fruition. So I think I'll just go through a couple of things that really have stood out for me that are still going to be happening this year. So last year, the Commonwealth heads declared 2023 as the year of the youth. So I am very happy and excited to see a whole lot of young people with in participants, and also some of our speakers are actually quite youth. And the second aspect is that we actually celebrated World Water Day yesterday, which we still basically trying to raise more awareness as the week proceeds. And we were following the theme accelerating change. And basically, this day is all about raising awareness and inspiring action to tackle the water and sanitation crisis that we are currently facing as developing countries, but globally as a whole. I think I would like to also just point out that this year we are going to be having our first non-sewage sanitation conference towards the end of the year, which is the first of its kind, and it's happening right here in South Africa. And last but not least, we cannot have this dialogue without necessarily touching on the UN Water Conference that is currently taking place in New York. Which is actually the first in 50 years since 1977 that is happening. And basically, it covers dialogues and talks about how we can actually do right in terms of addressing these water and sanitation challenges that we are facing. But this year as well, we have recorded a global population that has doubled to 8 billion. Approximately 8 billion. So those are just some of the statistics and the conversations that we need to be able to tackle, not just only in this dialogue, but going further. I would really like to go through some of our bios for our speakers. So today we will be having Ms. Lungizuma, who will be really trying to give an overview of how the UKZN and EWS partnership has started and how it is going currently. And then our next speaker after that will be Mr. Akash from eThekwini, who is a chemical engineer with the process engineering services branch of eThekwini Water and Sanitation Unit. He has over 15 years experience in the water and wastewater sector. Our second speaker would be Dr. Priyan Namnal, sorry, who is a senior research scientist at the WASH R&D Center, and she holds a PhD in chemical engineering and a biological scientist by training. Our last speaker will be Dr. Santiago Septian, who is also a research scientist and research engineer at the WASH R&D Center. He obtained his environmental chemical engineering degree and PhD in thermochemical processes for biofuel production. And lastly, we would be having some sort of a closing and also vote of thanks from the MILE team. And Janice will be able to cover those aspects. And I think if there is, of course, time, Smiso can also just give us a brief vote of thanks in that regard. So colleagues, allow me to invite our first speaker over to, give a brief overview of this incredible partnership, and that is Lungi Zuma.
Thank you very much, Sifiso. Just waiting for my slide to come up. Colleagues, as introduced, my name is Lungi Zuma. I'm from eThekwini Water and Sanitation, and I will be sharing on this one slide the history of the relationship that EWS has had with the WASH R&D Center, and previously the Pollution Research Group. So this mandate or this relationship officially started in 2006, but the relationship and the working together of these two institutions can be traced back to even the 90s. And the main goal has been to develop capacity for water and sanitation service delivery, researching the improved water and sanitation systems, and just to ensure that the projects that we are implementing are economically and environmentally stable. Let's say, for example, each of the institutions have different responsibilities under this relationship. So from EWS side, we provide the funding for agreed projects. We provide the problem statements that we need research on based on our priorities. We also provide research sites within the municipality. I think more importantly, we provide the liaison and facilitation with communities, because some of the projects that we undertake are within spaces where people live, and that liaison with them and the political side is quite important. And from EWS side, we've had, even wider eThekwini, we've had a few of our colleagues completing their masters and PhDs under this collaboration and doing projects within water and sanitation. And then from the WASH R&D Center, they provide recruitment and supervision of students, lab experimentation, the multidisciplinary approach. We don't limit ourselves to working only on the technical side. We also do some vast social work, agriculture disciplines. We've also done projects on that. And also access to international research teams and other departments within UKZN. And I think the most important thing about our collaboration is that it has allowed us to leverage for funds from other organizations for benefit of research in our city. Some of the organizations I can name that we've partnered with very greatly over the years has been the Water Research Commission of South Africa, as well as the Bill and Melinda Gates Foundation, which have provided a lot of funding into sanitation research and piloting within eThekwini. And some of the other projects that we've worked on over the years and are continuing to work on, we've got our Newlands Marshy research sites where we've done the decentralized wastewater treatments that Priyan will be talking about. We've conducted research on various aspects of fecal sludge management. One of our other projects that's quite important that the team at Process Engineering Services have been working on is the modeling of our wastewater systems as well as our water systems. Currently, we are within another funding cycle, which will end in December 2024. So the projects are still carrying on and the work is still happening on the ground. So thank you very much, Sifiso. Over to you.
Thank you very much, Lungi, for that brief overview. That was very nice and precise. I will call on our next speaker, who is Akash. Akash, I'm handing it over to you.
Thanks, Sifiso. Hi, everybody. My name is Akash Singh, and as Sifiso and Lungi have mentioned, I'm a chemical engineer with the Process Engineering Services, and I'm going to give you a brief overview of our modeling initiatives and the collaboration between EWS and WASH, previously PRG. From a municipal context, we find that we have a lot of challenges, and you can see just a few of them up on the screen. Now, in order to understand a problem, or in order to solve a problem, we need to understand it. We need to unpack it. And while there are the challenges you see in front of you are quite different and quite broadly defined, what we found is that there is a common approach to understand and resolve them. And it almost always consisted of some sort of data manipulation or data understanding, gathering, and modeling component. And we found that there's often an interconnection between the problems, either through the data requirements or a common solution approach. And this can be distilled down into basically what we're looking at is modeling for data and decision support. We want to take data, convert it to information that we can use to inform an action. And then that action creates new data, which allows for better actions and decisions to be made. And so this cycle keeps going. Now, the idea is to use modeling to effectively speed the cycle up by enhancing the way in which we can convert data to information, simulating what potential actions may be so that we can actually speed through the recursion. And in order to do this, what we found is collaboration is key. The sharing of data and experience is critical to make these types of projects a success. But more importantly, I think what we found is that we can reuse aspects of one project or another for more than the intended purpose. So for example, a model that we've developed for analysis of energy efficiency could be repurposed for risk analysis or planning. Wastewater treatment works could be used, wastewater treatment works models could be used as inputs to environmental models and so on and so forth. And so that's the type of thinking that we've been going with at Process Engineering Services and at WASH. Lungi's covered some of this. So the collaboration between eThekwini and PRG/WASH began in 2006, and there's been a strong modeling collaboration with the chemical engineers in EWS since the inception of the Memorandum of Agreement. In 2016, we actually formed the Process Engineering Services branch, which is effectively a branch of chemical engineers, and we're focused on process engineering work like modeling and design and so on. And so this allowed us for more robust collaboration in this modeling space, which is something that we weren't always able to fully take advantage of. And this has unlocked us the ability to do a lot of different things. And some of the collaborative endeavors we've been going for is modeling training, data validation, skeletal models, various different projects. In terms of modeling training, we've basically gone for your traditional modeling approach for wastewater treatment work. So this is, pure type of chemical engineering, steady state and dynamic modeling of wastewater treatment works. It's a core part of our graduate and training development program, and we've used the training that we've gotten from the university and that we've developed in application in our work day to day for conceptual designs, capacity verification, etc. And we've also shared this training and resources through our various outreach projects with the WRC, WISA, etc. One of the key points when it comes to modeling is the data and developing data pipelines. And often what we find is that in order to model a wastewater treatment works, the data requirements are quite intensive. So you need lots of samples, lots of readings, lots of meters, etc. But the quality of the data in the municipal context is not always great. It's not always available. So we've had to develop the tools for understanding the data, to take it from data to information. And this has been one of the most fruitful parts of this collaboration. The ability for us to actually take existing operational data that we use or that we already have, make do with what we have, and refine this data so that we can use it to develop models for decision support, etc. So together with UKZN WASH, we've developed tools to sort of fill in the gaps between the data, tools like the probabilistic influence fractionator. And these type of tools actually negate the need, for the most part, to go through expensive sampling and monitoring programs. And that removes a barrier to entry for modeling. And removing that barrier to entry has actually allowed us to develop what we call skeletal models. So these are sort of baseline models for our wastewater treatment works. And certainly we've developed the tools to very quickly put these together. And we can do things like basic input and output, capacity estimation, design calculations, scenario analysis, risk analysis. And we can go as finely as adjusting flow rates or optimizing flow rates in a treatment works and seeing how the system reacts almost like a digital twin type of model. Or we can sort of virtually take units offline to see what the impact is, do some sort of failure analysis, see how far and how long we can keep a unit offline, or a unit can go offline before it negatively impacts the treatment works. So this is the type of very granular process engineering type of work that this collaboration has been focused on. But we have been looking outwards because of the nature of the work that we're doing. So we're looking at the treatment works and what are sort of impacting forces and the inputs. And what we find is you can have informal settlements, unaccounted for water infiltration, pipe breaks. There's a whole lot of information that we don't understand about the catchment that has actually pushed us into a wider view of modeling. And that led naturally to the concept of integrated modeling, which is the union of many complex models. For example, linking climate change models to stormwater models, to wastewater models, to river models, to give us a holistic view of the situation in a given city or catchment. And in fact, this is our latest endeavor through the WRC. We're developing the framework and tools to actually to develop these integrated catchment models, again, using that sort of skeletal model approach to help us better understand our systems. With the ultimate objective, of course, being decision support. And what we would like to do is take those integrated catchment models and convert them into live SFDs, sewage flow diagrams. Now, sewage flow diagrams, I'm sure many of you may be aware, have become quite topical, and it's a visual representation of wastewater treatment in a given catchment, and gives a good understanding of a visual understanding of what's happening. And our goal is to actually convert the modeling outputs into this sort of live SFD type thing, where we can open up a dashboard and look at what's happening in the city, or what's predicted to happen in the city in terms of wastewater treatment, and use that as the decision support tool, obviously. As Lungi alluded to earlier, we've been heavily involved with collaboration with other organizations, and we've produced quite a bit of papers nationally and internationally, presentations, workshops, etc., with WISA, IWA, etc. So there's quite a large body of work specifically tailored to wastewater treatment modeling, and now the broader integrated catchment modeling as well. So much so that we together, EWS together with the university and University of Cape Town, are actually founding members of the WISA modeling and data division. So this is a division of WISA focused on promoting the use of models and support for modeling and data interpretation in the water sector. And it's really spearheaded by the collaboration between EWS and the WASH and the other academic organizations. So that's the general overview of what we've covered and the collaboration. I just want to talk a little bit about taking the modeling aspect forward. And Chris Brokart, who's a permanent collaborator with Process Engineering Services, he's mentored a lot of us for modeling, is very fond of saying all models are wrong, but some models are useful. And that's a quote by George Botts. That's a very important quote because it contextualizes what modeling really is. We are attempting to understand or simulate or replicate a real life scenario, but we'll never be able to get it 100% right. But we can make it useful. Now, during our engagements, another very important thing was said. A model can only be useful if it is used. If it's not used, you can never see the value out of it. And so what we found is that we're finding that we can develop the models, but we're running into brick walls. We're having barriers in terms of implementation going forward. And some of the barriers are, for example, confusion and lack of capacity, a lack of understanding of what a model is, or what modeling is, or what can be done. You know, sometimes there may be unreasonable expectations. And again, all models are wrong, but you know, what a model is not a magic future prediction box. And I liken that to the weather report. People often get mad at the weatherman when he says it's going to be sunny tomorrow and it rains, but that's just uncertainty in a model. They use models to predict the weather, and sometimes there's uncertainty and you don't quite get it right, but it's still better than not having anything at all. But really speaking, we need, it's important to have the capacity to take up the outputs in as much as we are developing these models and sending it out into the organization. These then need to be taken up. The baton needs to be taken up and taken forward. Decisions and confidence needs to be had to go with these things. A systems approach is needed. Needless to say, we can't talk about eThekwini without talking about the horrible run of bad luck we've been having recently. The video you see at the bottom here is of the Umbilo treatment works. You can see our northern treatment works basically underwater. So there's immense amount of damage that has occurred. That video, ironically, 2 hours before this video was taken, all of the process engineering services guys and the UKZN guys, including Professor Brokart, were actually sitting at the Ambilo treatment works, working on our modeling workshop while the floods were coming, and we just escaped the works before this washout. And of course, even without the floods, we've got a lot of aging, unmaintained infrastructure that will prevent full adoption of the nice to have optimization scenario application for modeling. Ultimately, though, we want to use modeling to take us from ad hoc planning to integrated master planning, to move from stagnation into progressive planning, to move from a state of confused analysis to a state of opportunity analysis and innovation, from risk denial to risk management, from bemoaning resource shortages to looking at resource optimization, and to prevent intellectual leakage and move to a state of business continuity. And this can be done by a fit for use approach, using models that for a purpose, and using and developing models for purpose that they are intended for. And that means model complexity can vary depending on the application. There's a potential for reuse and repurposing of existing models, and a potential for synergy amongst different organizations and different units. Importantly, and I think in conclusion, again, we have to say all models are wrong, but they can be useful for decision making. This does require an extensive and interactive process from the organization. Decision makers should be involved from the start and throughout, and the organization needs to be as dynamic as the models we develop. Thank you very much. That's the end of my presentation. Over to you, Sifiso.
Yes, thank you so much, Akash. So all models are wrong, but some are useful. I love that saying. I mean, I think maybe that's how we need to start looking at some of these innovative approaches and systematic approaches that we are trying to use to try and address some of these issues. Yeah, so what I got from that presentation, and I think from this first speaker as well, was the emphasis on collaboration, capacity building, and also really trying to unpack some of the problems in order to find suitable solutions to address them. And I think the most important aspect that this particular speaker really touched on was that is the data, the importance of data for decision making. But also, I think we've always just assumed that, well, it is known that the water industry is very rich in terms of data. However, it goes back to what is the actual quality of some of the information, and data that is being produced, and what is the access aspect. And I mean, we can't even get into the access and also the generation of sanitation data. So I think our next speakers will be very, very useful in really trying to address these questions. So if Dr. Priyan could please present. Thank you.
Morning, everyone. Okay, just give me a second. All right. Are you able to see my full screen?
Not yet on my side.
Now it's showing up on mine. Is it still not showing?
I can't see it on my side. Does anyone see the screen?
I can't see it either, Priya.
Okay, let me stop sharing and try again. Now?
No.
Oh, I don't understand what's going on. Okay.
Okay, maybe try once more.
Okay. Now?
Your name is appearing, but the presentation isn't.
That's so strange. I've done it 3 times. Okay, perhaps we can move on to the next speaker until I find out what is going on.
Okay, that's perfectly fine. So whilst Dr. Priyan is sorting that out, if Dr. Santiago Septian could make your presentation.
Hi, hi everybody. I don't know. I sent to Lungi an updated. I have also problems with my team. My team is becoming crazy, literally, when I try to share. I don't know why. But I sent to Lungi two presentations. Well, you can take the last one.
Lungi, if you could kindly share Santiago's presentation.
It's still trying to download.
I mean, I can try. Hopefully, let's go to close the finger. I want to try. I want to try to open it. Sorry.
On my side, it's still trying to download Santiago's presentation.
Okay, I will try to.
I don't have it.
If I disconnect, it's because my crazy. Okay.
Okay, whilst we wait for our speakers to sort out the presentation, does anyone have any questions, comments? Oh, okay, no, never mind then. Yeah. So
sorry.
Yes, Dr. Santiago.
So hi everybody. Thanks for the presentation. I am, as you told, a researcher at the Washington.
Sorry, Santiago, we've lost your presentation.
Broke the presentation. I will do it again. Can you see?
Yeah.
Sorry.
Yeah, we can see it.
It's a little. I'm sorry. The thing is, I don't know why it's failing. Again. Can you see it?
Yes,
okay, we can. Perfect. So thank you. Can you hear me clearly?
Yes, we can.
Okay, perfect. So I am Santiago, I'm a researcher at the Washington Center, and today I come here to present to you about the development of solar drying technologies for the treatment of fecal sludge from on-site sanitation facilities. So the sludge management is a challenge in South Africa, as you have to, the people from it have to know that. So this sludge includes the sludge from on-site sanitation facility as pit latrine, dry toilet. It's still sharing. Hello?
Yes, it is Santi. You can continue.
Okay. So and also sludge from wastewater treatment facilities. So there is a big amount of production of this sludge. However, this sludge is mostly water. So in order to reduce the volume and mass of this waste, it's important to remove the moisture. It's a very important step, and we can see in the figure how the sludge, after this is, we can see a picture when it's fresh, and when it's dry, we can see there's a drastic reduction of size. And also the drying, the process. Drying is a process that will allow to reduce the moisture in the sludge, and it's the most effective way to minimize the volume and mass of the sludge, and also disinfect the material, because when you remove moisture, you also can kill pathogens that are in the sludge, because the pathogens need water, and you're removing this water for a metabolism. However, thermal drying is an expensive process, because to evaporate the moisture, we require a high latent heat of water vaporization of 2,260 kilojoules per kilogram. So it will require a lot of energy in order to dry the sludge, and this will translate also in high OPEX. But also thermal dryers, it needs a big equipment, needs heaters, needs insulation material. So this also will lead to a high capex. So we need heat to evaporate to dry and evaporate the moisture in the sludge. We require heat, and this heat could be brought by solar energy, because solar energy is abundant in South Africa. Just some days in South Africa, we have 2,500 hours of sunshine per year. And the energy from the sun is lies between 4.5 and 6.5 kilowatt hour per meter square in one day. And in an annual 24 hours global solar irradiation, we have an average of 2,200 watts per meter square. So we can see that the solar and solar energy is an abundant resource in the African continent, and we can see in this map. We can compare with the rest of the world, and we can see the African continent receives a lot of sunshine, and also in South Africa also. This is in the same picture. So solar drying is a practice that has been maybe is one of the most ancient applications of solar energy of humankind. It was mainly applied for food industry and crop conservation, as we can see some pictures. Here we can see the picture when they are drying the fish. And with time, we have developed systems to dry the crops and food industry. But also in the case of more recently, they have been developed solar dryers for sewage sludge in developed countries. And here, for example, we can see a picture, an example. And the largest plant actually is found in Mallorca, Spain, which can treat 30,000 tons of sludge per year. So what is a solar thermal dryer? So the basic components of a solar drying system is basically, well, we want to capture the sun in an efficient way. So for that, we need an enclosure where we're going to put the material to dry. And this enclosure is going to protect it from the outside conditions, which can be rain, wind, etc. And will avoid it will avoid air losses. Usually, we can use a transparent material at the walls of the enclosure. Like this, the sun can pass through it, but it will be captured by the greenhouse effect. Inside the system, we can put material that can absorb the solar and thermal energy, which I call absorbers. Also, it's very important to have a ventilation system, because the material is going to dry and the moisture is going to be transferred from the solid to the air. So it's important to evacuate it from the system. And important also to have a air circulation to enhance the mass transfer. It's important also that there is gradients of air like wind inside the machine, that it will allow to dry faster by increasing the mass transfer. And for sure, we need some thermal insulation, piping, and instrumentation. And there's also some innovations that can be applied to the solar systems. For example, the floor can be heated by solar energy, also by solar collectors. They can be combined with PV, and we can also store the heat for the hours where there is no sun, and then release this heat. So there are other features that can be added the solar thermal drying system. So everybody of you has to know the classical drying beds where you put the sludge in open air, which can be also considered like kind of solar drying, but it's not as efficient as using a solar thermal drying system. Our conventional drying beds, that's what we use most of the time, are low cost because we only need to build infrastructure. But however, it can take a long time for the sludge to dry. And also can rain when Durban is very rainy, especially in summer, so the sludge can be wet again. It's also at the open air, so there can be pests, insects that can develop, and also there can be aerosols that can be with the wind. We can create aerosols, and this can contaminate the surrounding area. So it's not like a very safe measure. So the solar thermal drying system, it's true that we need a higher investment. It's not only an infrastructure, but however, it's going to be more efficient. We're going to allow to control the conditions, which will allow to lead to a more efficient drying, which will decrease the surface area required. And also we can pasteurize. We can lead to higher temperatures, so the sludge can also be pasteurized. And it's infected and it's going to be confined to sludge in an area. So no risk of contaminations of the surroundings, no risk of the sludge to get wet again after a rain. And it's also possible to automatize. So here is Washabi Center. Well, we already know it. So here we developed a program about solar. A few years ago, we developed a research and development program for sludge solar drying, and we wanted to develop systems, solar drying systems that could be later implemented in a community or in a EWS system or in a wastewater treatment plant, something that can be scalable. Like this, we can put it in different places, but also can be downscale. So it's important to be also downscaled if we wanted to implement in a community level. So the phase 0, that's what I call it here, it was a project funded by the Water Research Commission, and we developed a small solar thermal drying system, as you can see here in the photo. And this system was just to characterize the process. So we put a small amount of sludge inside this transparent tube, and it was there was a ventilation system, there was instrumentation, and so the material dried, and we measure different parameters, for example, the temperature, the loss of mass with time. So with this, we determine the kinetics of the drying. So we allow to kind of understand the process. And from this knowledge, we built a small bench scale prototype this was developed by mechanical engineer students, which is a small solar dryer. It was just like an exercise. It was not like a exercise, to put into application our knowledge. So here we got nice results, as you can see in the photos. In 3 days, we managed to dry a small layer of synthetic sludge, which is the white paste, and the black paste is real sludge. So you can see that in 3 days, we're enough to dry the material. So yes, this project finished, and we get some understanding of the process. We get some parameters of which temperatures we can achieve in this kind of system, the drying rate that we can achieve, with the performance, how much energy we could use, the electrical energy to run the fans, to run all the electrical equipment, and also to identify different challenges. So this is what we learn a lot from this project. And from this project, we have the idea why not to try to apply this into develop something that could be more real. And so here is the second phase of the solar drying project, also developed, also funded by the Water Research Commission under another project, second project. And we developed 2 systems. It is like the greenhouse solar dryer. It's a proper small greenhouse, and this is another screw conveyor solar dryer. This was developed was the concept was by me, but the students were participated also. There were two master students that worked each one in each prototype, and we have the help of our skilled technician to build all this equipment. So we also, part of this project was important to make a proper solar assessment in Durban. So we get data from the different years of solar energy we have a solar station at the mechanical engineer building. So we can get this data online by internet. So we try to get all the data that we get for the different months, the different years, and make an average. And also we get the solar maps that you can see here as a solar map of South Africa. So we could note that Durban is in the cold area of the country. It's not the hottest part of the country, but still it's quite good. If we see the values are in the range of Greece or the south of Europe or north of Africa. So it was still quite good. And we managed to do, with these values, we managed to do some extrapolation. So, for example, we could see that with these values, we could dry from 4.3 to 7.7 kilograms per day per meter square of moisture. An average of 6 kilograms per day per meter square. We could dry with the sun, theoretically, with the sun of Durban. And then how much this will require surface area to dry the second lodge. For example, to dry 12 tons per year, which is approximately what is produced for VIP. So to dry it from 80 to 20% of moisture content, we will require a surface of 5,000 meters square, which is 1/10 of a soccer pitch, which is not enormous, quite acceptable. This is if all the energy of the sun is transformed is used to evaporate, but it's not the case. There's always efficiency. So if we consider an efficiency of 0.3, which is quite normal for a thermal system, we will require approximately 7,000 meters square, which is 1/3 of a soccer pitch, to dry all the VIP lodge from Durban. So it's quite decent. So here's a scheme of the greenhouse solar dryer. So the greenhouse solar dryer has as the thing that I told you, they have the carbon ventilation system. We have this plate, absorber plate that's going to absorb the sun, solar energy. It's just a metallic plate, but it gets very hot when you receive the sun, and this can be transferred to the air, can be also radiated to the inside the enclosure. So yes, it will help to get high temperatures. The lodge is going to be placed in the bottom, in this thing, and the support, and we develop a rack system, which a rack system will allow to allow, in the drying bed, conventional drying bed, there is a bed, and sometimes there is a crust that is forming at the top. Here we have like this rack system that will avoid the formation of this crust, and will avoid also and it will also homogenize the different layers in the bed of the lodge. Like this, we'll get a more homogenized material, and also circulation fans. So here we have some results that we obtained with the synthetic lodge. So we could see the synthetic lodge was a starting moisture content of 80%. After 1 day, we dropped it to 70%. And this lodge was very sticky. This was an observation from the experimenter. And then the second day, we managed to decrease from 70% to 60%, and the lodge becomes more lumpy. And then from day 3, we have a big jump from 60% of moisture content to 10% of moisture content. That's the day we really start to dry the material. We even could stop the drying here, and the lodge become more like crumble, like a solid already. easy to manipulate, not anymore difficult, like sticky, like lumpy, not anymore like these characteristics. And at the end, we finished like a kind of granular sludge, 10% of moisture content, which is nothing. And here's some pictures that we took with a radiative camera. As I told you, the absorber wall can get very hot, 40 degrees, and the sludge can also get quite hot, up to 50 degrees. So it's a good temperature to pasteurize the sludge. Then we have the other system. The other system is the sludge is going to be placed in this screw conveyor. So it's going to be conveyed inside this tube. But this tube is transparent, so it's going to be heated by the sun. There's going to be air, and this air can be humidified and preheated with this equipment. And the preheating will be done also by a solar collector, also homemade. We can put reflectors in the sides to increase the amount of solar energy in the sludge. And here we can get high temperatures. You can see here even 70 degrees. Here's a photo, we can see it. So here, very similar to the other side. After 2.5 hours, we reduce the sludge from 80% moisture content, which is synthetic sludge again, not real sludge. We reduce from 80 to 50% in 3.5 hours. The sludge was very sticky, so we have a lot of convey challenges in this area. And we reduce these challenges by adding a little lime. So the lime has an effect to reduce thickness, not enormously, but it was a little improvement in the convey. And we also tested charcoal and sawdust, but no effect. And then when the initial moisture content was 65%, we managed to reduce to 45% of moisture content after 2.5 hours, and the sludge was lumpy. So it was a little more easy to convey, but not as easy, but still some challenges. And at the end, we do some experiments with 50% initial moisture content sludge, and after 2.5 hours, we reduced it to 30% of moisture content. And here the sludge was more crumbly, was solid, and it was conveying perfectly and dried very good. So after this, we tested different parameters. We test the effect of ventilation, air circulation, the rake system in the greenhouse, the humidifiers, air heater, reflector, as you can see here in this graph. For the greenhouse, what we note is that the optimum conditions were when the ventilation and the air circulation rate were low. So it's important that we have a little of ventilation and circulation, but the optimum results were when it was low flow rate, because when it was high flow rate, we noticed that the system tend to cool down, so it will reduce the drying. So it's important to have a little of air to evacuate the moisture, but not too much, because we will also evacuate the heat. And then rake system, we note that the rake system led to a faster drying, allows to dry faster by homogenizing it. However, it leads to a higher energy consumption, which is normal because it uses motors. So if we were using a little more of energy, but we dry faster. And then the screw conveyor solar dryer, similar with the ventilation, it's better to use flow rate just to remove the moisture. The solar air heater has a positive effect because it allows to bring more heat to the system. The reflectors, there was not really an effect. And the humidifier has a negative effect. Well, it really didn't affect the drying, but it uses a lot of energy. So it's something that we have to remove, a component we have to remove because it's not necessary. Some results that we got, we saw that we managed to get 10 to 15 degrees more inside the solar dryers with respect to the ambient conditions. So some days we even managed to have peaks of 50 degrees of the air inside the greenhouse. So we managed to get high air temperatures, because the temperatures that I showed you before, they are from the materials, not the air. But we managed to get air temperatures of up to 50 degrees in the very hot days. The specific energy consumption, which is defined as the kilowatt hours to evaporate 1 ton of sludge, was inferior to what the conventional thermal dryers use, which is between 800 and 1,000 kilowatt hour per ton. So we managed to see that we get lower sex, which is very good, and the efficiencies also were quite good for some cases. And we could see that the screw conveyor sludge dryer has a better drying performance, but it was more difficult to handle the sludge. So it was more impractical. The greenhouse were more practical, but the results were better with the screw conveyor. And we could see that we test also wet soil. I forgot to tell you that also we test wet soil and synthetic sludge, and wet soil was much easier to dry. That is why we have higher efficiencies and lower sex, because the wet soil is much better. And actually, we expect this real fecal sludge will be closer to wet soil than synthetic sludge, because synthetic sludge is the water is very bound. And then I will make a techno-economical analysis. So, already these values are in dollars, because it's, but I have the values in rands if you're interested. It is in dollars. So I make a small techno-economical analysis. There was a lot of assumptions, so it's not very precise. It's just very rough, and it was based on how much the cost to dry the pit latrine sludge in the eThekwini municipality, which is 12 tons per year approximately. So to dry it up to 20%, which 20% is a value that can be considered safe. It's solid, looks like soil, and so we could see that you have very low running costs. As you can see, the low running costs can be very low. So to treat 1 ton of sludge will be $34 for a greenhouse and $9 for just for 1 ton of sludge. $9. And this is quite low. However, which is normal because we only use a little. We don't use the energy when you dry. Most of the energy comes from production of heat, but here the sun is providing us this heat, so we only have to use fans, electricity to run the fans, instrumentation, and some motors. So it's quite low. All electrical, mechanical things, which uses a little bit of energy. And then, however, we have very high capital costs, like millions and millions, but this is normal, so don't be afraid. This is because it's a prototype stage. So all what is prototype is extremely expensive. It's not representative because the for sure is not optimized at all. The system, the cost of the materials, we buy it individually, not in bulk. There's no economy of scale. So it's normal that it's very expensive. So we don't have to consider it too much. I just put it as an indication. And something very good that we could see, like for both systems, will require a low surface area footprint, which be half of the soccer pitch. So the conclusion is that there is a great potential because we have a low energy consumption, low running cost, and low surface area footprint. And we expect in the future improve the systems, and in the improvement of the system and optimization of the operating conditions, we will decrease the running and capital costs. And also we have areas of improvement and optimization that we found. Here we can see them. This is some areas of improvement in the entire pilot. So for the next round of tests, we already identify what we can do it. We can optimize the rec system. We can optimize the ventilation, decrease the size of the ventilation because we saw that it's not necessary that it can be just very mild, so we can reduce the size. so reducing the cost and running costs. So there is many things we can improve. We already have some hints where to go, and we expect to decrease a lot of the cost. So the next phase 2, which now we're in the phase 2.
Doctor, you've got 2 minutes.
Okay, no, that's perfect.
Yes.
Almost finishing. So here we go. So this is the second. We're starting the second phase now to test these new technologies with the Royal Academy funding. Here is some planning. So the tests are going to be done in the mushroom. We already select the field. We are just preparing it. So we're going to develop there in the Milas mushroom place where to test the solar dryers. So here is going to be much more people, but what is interesting to see is that the Melvin Pillay, engineer from eThekwini municipality, is doing a master without half-time master with us. He's going to be involved in the prototype testing, and also Trishandra from Mugeni Waters, another part-time master, that are going to be involved in the testing of the prototypes. We have collaborators in this part of the project, Swansea University, MUT, that are going to bring interns. So there are going to be interns that are going to help the master students, Trishandra and Melvin, to do the experiments, because they are very busy during the day with their obligations in Ungeni and the eThekwini municipalities. And they will have also the support of Kenisia Project and Virusan. So that's what we wanted to test. We'll try to make several iterations. With these iterations, we want to improve the system. And we also want to do some CFD simulations. Apart from the test, we're going to do CFD simulations. And we have a partnership with Swansea University that are experts in CFD simulation to see how we can improve the system with that tool, and also plus the data that we'll get in the field. So, and then the phase 3, we hope to start this year with the more commercialization. We hope to arrive to a nice, this year we hope to arrive to optimized and good design of the solar dryers, and to talk with the WRC next year to see how we can go forward, also incubate from UKZN. There are many, or TIA, there are many possibilities that you can help us to go there. eThekwini. And that's it. Thank you very much.
Thank you so much, Dr. Santiago. I think that was a very, very detailed and quite interesting presentation, very insightful. I think it actually says a lot about the caliber of evidence-based research that is currently being undertaken at UKZN in collaboration with the city. I will then call on Dr. Rian. I'm not sure if you are able to share your presentation now.
I'm gonna try now. Able to see my screen?
Yes, we can. If you could
Perfect.
just put it on presentation mode.
Okay, perfect. Okay, morning everyone, and thank you for your patience. I must apologize for the technical glitch, but I'm hoping you'll be able to understand more about DWATS and its history here in eThekwini. So the title of my presentation is DWATS Bridging the Gap Between the Served and the Unserved. And this mainly relates to a solution, a sanitation solution towards providing sanitation services for those communities that are within urban and peri-urban areas that technically do not have any sanitation services or have temporary sanitation services, and looking towards bridging that gap between those that do not have any services and those who have. So I'm just going to give you an overview of what the presentation would be like, and providing a history of DWATS research in eThekwini, which started all the way from the 1990s in terms of concept forming and the design of such systems. the lessons that we learned from the first demonstration scale decentralized wastewater treatment system in eThekwini, and what are the steps going forward in terms of bridging this gap. So in the beginning, it started off with the concept of the anaerobic baffled reactor, and it's a novel way of treating domestic wastewater, especially in this regard. It went on to a laboratory scale system looking at a 5-liter a lab scale ABR. So essentially what this system does is that the raw wastewater enters into the chamber, and as it baffles through the walls that act as baffles, there's sedimentation of the organic matter, and the wastewater is treated by the anaerobic bacteria that are present within the reactor. And then it ended up in 2001 with a pilot scale system at the Kingsborough wastewater treatment works. So the idea really started with looking at the unserved and informal communities that that were, I wouldn't say infiltrating, but became more densely populated within the urban and peri-urban fringe, within fast-growing cities such as eThekwini. And this is mainly due to rapid urbanization, which is often uncontrolled, and these communities essentially looking for better livelihoods and access to jobs and services, and a better lifestyle. And often in terms of providing services for these communities, although alternative technologies may be more apt, for example, providing waterborne sanitation for these communities is not always feasible, based on the fact that if these communities lie outside the sewer boundary, it does not make practical sense to then extend and provide the capital costs for extending that sewer network. However, most of these communities still desire waterborne sanitation, and you know, in the sense of a flushing toilet, which is often regarded as the gold standard in sanitation provision. So this sometimes pressurizes municipalities in providing these types of toilets at the household level. However, even if connections to the sewer is possible, most conventional wastewater treatment works operate above their hydraulic capacity, and this is basically due to the rise in rapid urbanization, which leads to these densely populated communities, aging infrastructure that was not really designed for such high loading, and obviously with infrastructure not being maintained on time. So this really led to the concept and the option to use the ABR technology in these communities and providing a decentralized solution to sanitation provision, where flushing toilets were provided with. And as the other speaker spoke of the MOA that existed between the then PRG at the University of KwaZulu-Natal Pollution Research Group, with one of the projects coming out of this MOA was testing the feasibility of decentralized sanitation for communities within the eThekwini municipality. So what is nice about the eThekwini municipality is that it gives researchers like us the opportunity to apply our research in the field and understand these options under real life conditions. It started off with the Newlands Marshall Research Site, which is just a community slightly about, I think, west of Durban Central. And the site was commissioned in 2010. And it started off with the layering down of an anaerobic baffled reactor, which was then connected to an anaerobic filter. Essentially, an anaerobic filter is one that it's a two-chambered system, can be a single chamber. It includes gravel media at the bottom that further allows for the degradation of the organic matter that is coming in from the raw wastewater. So the system was designed to include constructed wetlands for tertiary treatment and included a vertical flow constructed wetland and a horizontal flow constructed wetland. Essentially, both these wetlands differ by the direction of flow or the just looking at the hydraulic flow through the system, with vertical obviously flowing downwards, while horizontal flow following laterally through the system. So this is just some of the construction of the decentralized solution that was envisaged for Newlands Marshu. And in May 2015, this is what the system looked like. Essentially, this is when I started off my PhD looking at the system as a whole. Originally, the eThekwini municipality had designed the system to be integrated with agriculture, whereby the primary and secondary treated effluent from the anaerobic treatment modules, which was the ABR and the anaerobic filter, to be integrated with agriculture because of the high nutrient content that came out of this secondary treated effluent. The system currently was allowed to treat the raw domestic wastewater originating from about 84 households within the area. These were low to middle income households. And it must be noted that this site nor the community was not selected for a particular reason based on their income, socioeconomic status, but rather to the fact that this the location of the site allowed for the raw domestic wastewater to be rerouted to the site that was already owned by the eThekwini municipality, and allowed for these field trials to be conducted. So as you can see here, this is some of the agricultural trials that were conducted using the anaerobically treated effluent. These results have been documented in many research papers, and you can visit our website to download some of these publications. But when I started my PhD back in 2015, and being a biologist by training, I was quite interested in the performance of the constructed wetlands, which they seem very biological in nature, in the sense that they are engineered to mimic natural wetlands, but in a controlled manner in which you can manipulate the design configuration to suit the type of wastewater that you're treating. In which case, this was raw domestic, secondary treatment treated domestic wastewater. So our target here was really the nutrients, not so much of the organic fractions, but really the nutrients in terms of ammonium and nitrate that was produced during the anaerobic treatment of the raw domestic wastewater. So I'd like to echo this, and my mentor, Professor Chris Buckley, always used it in his presentations. And funny enough, I also like to affiliate with this quote by the famous engineer Edwards Deming, who stated that without data, you're just another person with an opinion. So we had the system operating for, at that time, about 6 years. And from the data that we had produced looking at the use of the anaerobically treated effluent in agriculture, it showed that this was a viable option. But how does it really bridge the gap between those communities who are served with safely managed sanitation services, in the sense that flushing toilets and the waste and excreta going through a sewer system down to a central wastewater treatment works for treatment. And those communities with no services, with no toilet facilities, or even if there were temporary facilities, what is to happen with that generated wastewater? So we started to look, in fact, my PhD was closely aligned to the constructed wetlands and how we could actually improve the design with minimal effort to improve the quality of the final effluent coming out of the system as a whole. So in 2020, I was able to, with the help of the Bremen Overseas Research and Development Association, was essentially the design of the site was essentially based on the border design principles of DWATS, who really conceptualized the concept of decentralized wastewater treatment systems. And what we did actually was redesign the vertical flowed constructed wetland just to improve the hydraulic, the distribution of wastewater across the surface area. As you can see here, at this stage, we had removed all of the invasive species that I showed in the previous slide and planted them with indigenous wetland species. You're unable to see it here, but we had just, these were just the, just at the time of which we planted those rhizomes. We selected 2 species that were locally available within the site, I think about a 10-kilometer radius. But essentially what we did was that we compacted the media, as you can see, simple media just consisting of sand and gravel. Improve the distribution by just including smaller diameter pipes and increasing the number and allowing for the perforations to be to alternate such that we can have maximum sort of a temporal flooding of the wastewater as it is released onto the surface of the bed. And with the compaction of the media, we had slow percolation of the wastewater through the media to allow for maximum nitrification of the ammonia in the anaerobically treated effluent. And in the horizontal flow wetland, also we removed all of the invasive species, planted it as well with the same species, Tifa capensis and Cypress sexangularis, which, like I said, locally available wetland species. Right here is a river, and we were able to get most of the plants for planting into the constructed wetlands. In this, in the horizontal flow wetland as well, we just compacted the media, cleaned out the pipes, and originally what we had was just grab sampling through various points in the entire system, but we found it more beneficial to have composite sampling. So by 2021, we had fully operational sampling sumps at the end of the vertical flow wetland and the horizontal flow wetland to allow for more accurate representation of the type of the quality of the effluent coming out of each constructed wetland. So there was a need to produce data as to how the system worked in terms of discharge of the final effluent. And in the study, we looked at the system operating continuously over a long period of time. By then, it had was in operation for about 6 years, whereby the raw domestic wastewater that was rerouted from the 84 households flowed into the DWATS, into a primary settler, which just allows for the settling of the solid matter, and where an access point for scum removal is done. Unfortunately, with South African communities and based specifically on the type of diet that we have, we find that the scum produced has a high fat, oils and grease content, which allows for a very thick layer of scum that forms on the top, which needs to be removed weekly. And thereafter that supernatant flows into the ABR, following into the anaerobic filter, and then into a mechanical dosing device referred to as a siphon, which then intermittently feeds the vertical flow wetland. And based on the design of these type of wetlands, in that they are intermittently fed to allow for the highest performance of these type of systems in terms of their treatment efficiency, which targets ammonium removal. And thereafter, it flows continuously into the horizontal flow wetland here to allow for a denitrification, removal of whatever residual E. coli that is present within the anaerobically treated effluent, and the total suspended solids as well. So the purpose of this study was really to, so we've already assessed the integration of DWATs with just the stage in agriculture. The focus of my PhD was to look at the entire system and determine whether the effluent quality is safe for discharge. So this study took some time, and unfortunately with the COVID pandemic, we had interferences in our sampling campaign. But this just gave us an idea of what the effluent quality was through the system. This was taken in 2019, so before the COVID pandemic. And we performed a 16-week, excuse me, a 16-week performance evaluation of each module of the DWATs to compare the final effluent quality. And what we actually want to focus here is the final effluent. So looking at the effluent coming out of the horizontal flow constructed wetland, excuse me. And as we can see here, and I want to really compare it with the other slide, but which has the general authorization limits for safe discharge. So let's go on to the next slide so you can have a comparison. What we did here after the COVID pandemic was compare the horizontal flow constructed wetland effluent under continuous operation. So this was no breaks in the flow. So the system was operating continuously compared to the COVID pandemic, whereby due to the absence of the technicians out on site, descumming could not occur. And interestingly enough, on the day that the national lockdown occurred, there was a blockage on site, which prevented any flow going into downstream into the DWATs for treatment for more than 162 days. So when we returned to site after that, we removed the blockage and the system was allowed to restart. We evaluated the final effluent after about 9 weeks of operation, just to compare the effluent quality and the time it takes for the system to start up. If we compare the organic fraction, and this is just a COD, so the biodegradable and non-biodegradable fractions, we see that the chemical oxygen demand is still within the general authorization limit. We couldn't really say much about the ammonium concentration because it was really the evaluation of the startup time in this aspect in 2020. But what we can see consistently that was fairly high was the nitrate concentration, which essentially stipulates that denitrification was quite poor during the continuous operation of the system and during the startup or recovery performance data. all the other parameters more or less within the general authorization limits. And in this column here, you could see the percentage of samples achieving compliance. And as we know, with green drop certification, whereby effluent quality is one of the performance indicators, 90% or above is required for the chemical, physicochemical, and microbiological parameters. So the areas of concern were really the poor nitrate removal. We were not too concerned about total suspended solids because the sumps were fairly new, and we believed it be due to the how we actually sampled, because we actually we had to use a submersible pump to pump the effluent out, and that could have suspended material that was stuck onto the walls of the sump. And that led to a higher total suspended solid concentration. E. coli as well was the percentage of samples achieving compliance was 83%, which is fairly good, considering that the system is subjected to high loading, such as if one household, for example, has an E. coli infection and high diarrheal, there's a high diarrheal input into the system, that can spike the E. coli content. So we were majorly concerned with the nitrate removal. So what does this actually mean? Based on the data, safe discharge of the final effluent is not possible on a continuous basis. And we identified that to be due to the design limitations of the horizontal flow constructed wetland. When we looked at the biodegradable COD entering into,
We've got 2 minutes. Sorry.
Okay, I'm almost done. Thank you. Going into the horizontal flow wetland, as we know, with denitrifying bacteria, they require carbon or organic matter, which provides the electrons required to convert nitrate into nitrogen gas. So the lack of biodegradable COD in technically the VFCW, the vertical flow wetland, prevented or resulted in poor denitrification in the horizontal flow constructed wetland. Moreover, the gravel media was mixed in the wetland, and that prevented enough of a hydraulic retention time. It was loosely packed and irregular shaped. So minor design limitations, but that impacted on the effluent of the quality. So where to next? We, with the engineering and looking at the design of these systems, we can learn from the best practices of other countries, and especially in Europe, where they've used the two-stage vertical flow constructed wetland to improve nutrient removal. And another option is to remove nitrogen at the source, such as the integration with urine diversion flushing toilets, whereby this also provides us the opportunity to separate the urine for maximum resource recovery. And this is based on some of the assumptions that Dr. Chris Brockart had formulated based on the lessons learned from European design. Excuse me. And as we know from data that the majority of the nitrogen and phosphorus load from domestic wastewater comes from urine. So through the reinvented toilet challenge, we were able to evaluate one pedestal urine trap, which was able to separate at least 75% of the urine. So based on these assumptions, if we had to look at the combination of combination of urine diversion flushing toilets, as well as a two-stage constructed vertical constructed wetland, we see that Without wetlands or urine diversion, these are the concentrations of ammonia and phosphate that will be present in the final effluent. Obviously, with no wetlands, nitrification is not able to occur, so that will prevent the conversion of ammonium to nitrate. If you have wetlands but no urine diversion, there's full nitrification, but that still means that the nitrate concentrations are fairly high. And as we can see from the discharge limits, the general authorization for nitrate is 15 milligrams. So looking at the maximum limit here, that would surpass the general authorizations, and safe discharge is not always possible. With no wetlands and urine diversion means the same thing, that denitrification is not allowed to occur, and that can surpass the discharge limits for ammonium. But with both technologies in combination, there is a possibility that we can achieve fully a safe discharge quality that can meet the general authorization limits. And moreover, it provides the opportunity to use that collected urine in the circular economy, and looking at entrepreneurs who can utilize that urine for fertilizer, etc. So that is the end of my presentation, and I hope you're able to get a gist of the concept of decentralized sanitation. It is not a non-sewage sanitation technology, but rather a decentralized approach to fill the gap of where waterborne sanitation is provided for communities such as institute informal upgrades of informal settlements to formal housing, where waterborne sanitation is then provided and provides a solution for the treatment of that domestic wastewater. Yeah, and I know that many may argue that non-sewage sanitation is the future, and I totally agree with that. But what happens in the interim? DWATS can definitely provide a solution for treating that wastewater, providing a fully safely managed sanitation services for these communities, so that the treated output, being the effluent, can be safely disposed of, or even used for watering the garden, and still in irrigation, since that some nutrients are still present in the final effluent. Thank you for your time, and I must apologize again for the technical glitch, but I'm hoping you are able to take home the importance of wastewater treatment, and it not just sits at the toilet facility. A safely managed sanitation services moves right down to safe reuse or disposal of the treated output. Thank you.
Thank you so much, Dr. Priyan, for your very insightful presentation. I think we are all quite impressed with the amount of work and detail that most of the speakers had spoken about on the various projects. Colleagues, on the interest of time, we can take a few questions right before I give the floor to Janice and Smiso. I see a hand. Oh God. Okay. I see a hand from Garabello. You can take the floor.
Okay, thank you very much, Sifiso. Great presentation, Dr. Priyan. That was very, very insightful. It was very interesting, I should say, and with the data that she showed, it was just some of the concepts that we're missing, because I should say, I should actually commend you for the technology that you developed over the years. It is very impressive. I am a bioremediation specialist also at the University of KwaZulu-Natal. And I'm very concerned with the data that you showed, showing that you are treating wastewater and you do not show the influent chemistry. However, you are emphasizing data on the effluent and also showing the cracks of your data, which is, of course, challenges that you highlighted that they are a concern, and they are a very great concern given the fact of the toxicity of nitrates, which is what most current technologies they are looking into. I mean, if you are to release water with such high concentrations of nitrates, even with the Certification National Standard of Water Control, it does not allow the disposal of nitrate contaminated water at a concentration above 10. And yours, it did show run about a minimum or run about the average of 40 to run about 60 as an effluent. Now, do you think with the concept of treating water, and of course, yes, thank you very much for showing the tables. It is quite a concern that do you think with the developments that you do have an anaerobic section in your pilot plant, and you are also emphasizing the fact that denitrification, which I did my PhD in particularly, don't you think that should be a reactor or a channel where denitrification takes place before you release the water into the river or into the environment? Because it is a concern with the eutrophication that can take place, with the toxicity of nitrates in the rivers that can definitely affect the zooplanktons and all the life that we find in water. And also given the eThekwini challenge of the E. coli that you are also still not necessarily removing entirely from your effluent. Those are my questions. If you can just pick them up in a sequence. Thank you very much.
Yeah, thank you so much, Karabela. Dr. Priyan, if you could just briefly answer those questions, and if need Dawn, you could also answer your question after Dr. Priyan has answered. Thank you.
Thanks, Carabella. That was a very good insight, and I'm going to briefly answer it, and I'm happy to engage with you after this meeting. So as I said before, the system had already been commissioned in 2015 when I joined to start my PhD. So I focused more on what could easily be done. Unfortunately, with the way that the system was designed, we could not do regular regular influent characterization. I'm not sure if you can see here in the corner of this picture, and I've put it very I tried to cut it out because this was unfortunately not very successful, in that we constructed a sort of a large sampling auto sampler, a whole effluent sampler that was based on a JoJo tank, and it had a macerating pump so that it allowed us to actually it was designed so that we could take intermittent samples to do an influent characterization. And you're very correct. For these type of systems, and especially with those with biological in nature, influent characterization is very important for us to understand what are the design characteristics of these systems and how we can size them, use particular media, etc., to maximize the treatment efficiency of these systems. So that is the gap for us. We were hoping to do that in the next round when we actually have actual data. This was originally designed based on the border design guidelines, and we used those criteria based on the quantity of wastewater that would flow into the system, and that is essentially incorrect. And as I mentioned before, there are many factors that contribute to the characterization of the wastewater based on your diet, people's cultural what they actually dispose of through the into the drain and down their sewers. So that impacts, and that is what we are hoping to find out in the next phase, when we actually have the opportunity to look at another community where we can initially measure the influent and then base the DWATs on that. I put this diagram here, and I must apologize if I wasn't clear enough. These were just looking at the different treatment modules and looking at it across, and the degradation of the various um, um, parameters across the DWAT system. If it is gray, means we wouldn't measure it either because it wasn't present, and it was not necessary to measure it. But we were now I did use the general authorizations, which is in the revised edition, the Government Gazette in 2013. So your idea of using 10 milligrams, maybe yes, less more stringent, but we used the one for the safe disposal based on the Water Act. So yes, it is concerned, and we plan to modify the design of the constructed wetlands to allow for us to maximize denitrification. The data, sorry if I'm going overboard, but yeah, let's take this conversation
Yeah,
outside.
please.
And
Yeah,
it's very technical, so yeah, but we are looking at it. It's not been overlooked. We are looking at the best way for us to get as much data as possible to improve the design. Thank you.
Thank you very much, Doctor. Nidon, I saw your hand up just briefly. If you could just raise your question.
Thanks. My question has been answered.
Okay. Thank you very much, colleagues. Now I will hand over to Janice to do a short closing, and then after Janice, if you could just give the floor to Smiso.
Okay. Good day, everyone. Thank you for attending and participating in this webinar. Special thanks to our presenters for the insightful and informative presentations, which showcase the valuable partnership that eThekwini Water and Sanitation has with UKZN. The city has for many years an MOU with various academic institutions, and this webinar is an example of the evidence-based research collaborations which exist within the partnership. This webinar is possible through our partnership with eThekwini Water and Sanitation, UKZN, and DIRA. In closing, MILE is the city's platform to drive knowledge-sharing initiatives like these, and we hope that you will join us for future engagements and learning interventions. Presentations along with the video recording and a learning note will be sent to all participants present. Enjoy the rest of your day, and thank you.
Thank you so much, Janice. Smiso, if you can just come through.
Right,
yes.
Thanks a lot, Simply, and thanks to Janice, and then thanks to presenters. Maybe before I say anything, maybe can I pose a question, especially to our EWS, our officials? You know, I'm a resident within eThekwini. I just want to know, like, what is the condition of our wastewater treatment plants? You know, the post floods. You know, because after the floods, especially around June, I think between June and September, most of them they were pretty much damaged. You know, have we recovered yet? You know, I'm asking this because the moment people know that you are working for the city, they ask us this question. So maybe if our officials from EWS can they share some light on the status of our water of our wastewater treatment plants? You know, are they in operation? If they're in operation, is it full capacity, or maybe 70 or 80% if they can maybe respond along those lines? So then when the general public asks us questions, we give them correct information. Then if they respond on that, maybe then I can do the official close of these things. So the question is not addressed to any specific person, but any official within EWS who might have information around the conditions of our wastewater treatment plants. Thanks.
Thank you very much, Smiso. Just wondering, Akash, are you able to take that question?
Hi, Lungi. I will endeavor to. Smiso, I think you know, often with these things, it's probably best to liaise directly with the SANOPS guys, but I will give some comments. I don't want to misrepresent them as well. I think you've seen from the slide that I showed, the damage was quite extensive last year. You know, in the hundreds of millions of rands worth of damage, and that so the works at present are still not all of them, but a few of them are still quite hampered. And there are projects on the go. I think the last presentation I saw, there were some 20 some odd projects on the go, and we've had to get grant funding, etc. I think 7 are completed, but there's still quite a bit more to go. But I think maybe if you can contact me or Lungi offline, we can put you in contact with the people who can give you a definitive answer.
All right, so thanks, Akash, and thanks to Long. I'll do a follow-up on that aspect, because it's quite an interesting thing, because the moment we engage with the general public, these are the sort of questions that they ask us. And as an official, sometimes it's embarrassing, when someone asks you about the function, the municipal functions. As a municipal employee, you said you don't know. So at least now I will know, what to say. And also, who to point them, because, if you're an employee within eThekwini, the general public, they expect you to know everything about the functions of the city, which is a bit of a big task, considering that our city is not just a municipality, it's a metro. So we've got different functions. The last I checked, there's thousands and thousands of municipal employees are involved in different projects. So anyway, on that, I think colleagues, thank you so much, for attending, especially our colleagues from UKZN. The amount of work that you guys are doing. Yes, to some of us, I'm not an engineer. Some of it was a bit too technical for me, but anyway, it did help me, to understand, these things, because sometimes we tend to underestimate, the work behind the scene. For example, you don't understand what it's take, the amount of work that is needed for you to get a potable water. When you open your tap, the clean water comes in, but you don't understand, the people involved behind the scenes. So it's always promising and encouraging to see, the positive and quite groundbreaking research that has been done, by our academic institutions. And as my colleague from mine just emphasized that for us in the city, yes, we are involved in implementation, because it's a function of local government. But you just want to make sure that whatever that you're implementing, it's guided by science, it's guided by research, because at the end of the day, for us within the local government, we don't have time, to undertake or involve in the research. So we rely heavily on the partnership that you are having with our fellow officials from UKZN, not only UKZN per se, because Mile just finished, I think they were circulating an MOA, where different institutions in South Africa are signing, and then also even outside of South Africa, if I'm not mistaken, because Colin Pillay from Mile did share the signed version to me. I think I saw one or two academic institutes outside of South Africa are committing themselves in saying that they are open to work with us. That shows that as much as we are in the local government space, but we do understand that our work should be guided by research. And then we on this instance, we quite recommend the work that we've achieved through collaborating or through partnering with our UKZN. We know that our water and sanitation guys have got a long history of working closely with our Wash and R&D Center through the late Prof. Chris Barkley, as well as the former head of EWS. And then on our side, from the side of environmental planning, we do have the Durban Research Action Partnership, DREP, it started like I think more than 10 years ago, just to show that we want to be guided by research and everything that you are doing, because that's where we feel that there's a direction of implementation, whatever that you are implementing, it needs to be guided by it needs to be guided by the data as well as by evidence research, so that's what we are emphasizing on. Thank you so much, and then we'll continue hosting having these webinar sessions, because at the end of the day, we want to make sure that even at the work that has been done at our academic institutions, it's directly talk to the work that you are doing within the local government sphere, because we don't want to have a situation where there's a huge gap between what has been researched in our academic institutions with what we are doing within the local government space. All these two functions need to talk needs to talk to each other, because we do need each other, You guys, you want to make sure that whatever that you are researching, you get implemented. And then on our side, we want to make sure that whatever we're implementing, it's something that has been tested somewhere else. So on that note, our colleagues, keep a close eye on these webinar sessions. This is not the last, we always try to have them at least one webinar session per quarter. So for this quarter, we are done. So the next one will be between, I think, from April until our end of financial year, which is June. And then again, we rely on our partners. Lungi will circulate the invites for officials within EWS, as well as our officials within UKZN. I think Prashni Singh, who's our direct coordinator, she's on the call. So for our officials at UKZN, keep a close eye on those invites, because we want to make sure that we keep this communication going on. And then if there's something from the side of the local government that you feel that might be of interest, you can always, be free, to share it with us. On that note, I will also thank our chair for today, Ms. Lamini. Thank you so much for the fantastic job that you did. And to the speakers, as well as to all the participants, we need to applaud, the time that you've taken. I know that all of us, we're quite busy with other things, academics, I know that it's quite a busy time. You're busy finalizing our students' registration, their lectures, as well as your normal research that you're doing, but take 2 hours of your time and then for free, and then you give it to us. We really applaud that. And then to our officials within EWS, as well as large municipal officials, we really appreciate the time that you've taken. We always rely on the support that you are receiving. So on that note, our colleagues, I can officially close this webinar, and then with the hope that the next webinar we will see each other, even if it's not on the next webinar, but we can continue engaging on these matters, through emails or through calls if it needs to be. We are open to engage and collaborate, because we are trying by all means to move away from working in our little corners. On that note, our colleagues, unless if Lungi or maybe Prashni want to say something, on my side, I can say this webinar is been it's coming to an end, unless Lungi or Prashni, you want to say something. If not, then our colleagues, enjoy the rest of the day. Thank you. All right, so I get a thumbs up from Lungi, so meaning that there's nothing from her side. And I hope, Prashni, you don't have anything to say, but if you do, please, you can say 1 or 2 words. Otherwise, if not, our colleagues, enjoy the rest of the day. Thank you so much for joining us. Until next time, thank you, bye.
Could we
Thank
please
you,
take a
bye.
group photo
Thank you.
before everyone goes? Can we please take a group photo, just screenshots of the webinar?
Oh, no, it's fine. So let me, so for those who
Okay.
can open their cameras, I think it's
Yes,
nice,
please.
can we all try to open our cameras? Okay.
Okay. I'm trying to. Hey, if you could just bear with me. I want to think of the gallery view. Okay.
Okay, who's taking the picture? Is this you? All right, so you just tell us once you're done then.
Okay. Okay, so I want to move to. Yeah, I think I'm done.
All right.
I'm done. Thank you.
All right, thank you so much.
Thank you.
Enjoy the rest of the day. Thank colleagues. Thank you so much. Bye.
Thanks, bye.
Cheers, everyone.
Thank you very much.